Hello everyone, welcome to the video tutorials on simulation of sliding window protocols using C programming. It is assumed that you already know the sliding window protocols in detail. So starting with stop and wait protocol. In this protocol, the window size is always 1. That is, one packet is sent at a time and we wait for the acknowledgement. When the acknowledgement is received, the next packet is sent. In this program, uh, I is used for the counter of the number of packets. N is for number of packets and we have initialized N as 5. R, the role of R is explained later. A is used for truth or false value of the acknowledgement. So in this for loop, we are running the counter from 1 to the number of packets, that is 5. We are printing which packet is being sent. R is rand modulo 2, that is it will generate value either 0 or 1. Here if acknowledgement is not received, we want to print timeout and resending. So uh, therefore R is used. If R is 1, A is the truth value, that is 0 or 1. If A is 0, then no acknowledgement number will be printed, and if A is 1, the acknowledgement number will be printed. In else part, we are decrementing I because acknowledgement number is always plus 1. So let's run this program and see what the output is. Here number of packets are 5. First, the packet 1 is being sent. The acknowledgement number is 2, that is the packet is received. Therefore, the next packet is being sent. Due to the value of R, we are seeing the timeout and reset. Since R is generating randomly, we are seeing for 2 times. Now, value of R is 1, but we are seeing no acknowledgement number, that is A is 0. Therefore, we see no acknowledgement number 3, that is packet 2 should be resent. Likewise, 5 packets are sent, and lastly, the acknowledgement number, we get acknowledgement number 6. Now, let's move to the next protocol, that is go back N. In go back N protocol, suppose we have window size of 5 packets and we get acknowledgement number of 3. Then we have to send packets from 3 onwards, that is packet 3, 4 and 5 again. In this program, we have variables window size, sent, ACK and I. Sent is initialized to 0. Window size is our size of one window. Our program is only for one window and not for the whole transmission. We enter our window size from the user. In this while loop, another for loop is introduced. In this for loop, we print which packet is being sent and we increment the sent. If sent equals window size, we break our for loop, and in the while loop, the ACK is randomly generated. Here, if we had used window size and not window size plus 1, then this for loop would have while loop would have been gone into infinite loop, as ACK would never have been equal to window size. Here, if ACK equals window size, we break our loop and the program is terminated. If ACK is not equal to window size, then we reset our sent to ACK so that we can send our packets again. Now, let us run this program. We enter window size as 5. Here, all the frames have been transmitted. Here, we get last ACK received equal to 3. That is, we have received packet 2. Therefore, we have to resend frame 3, 4 and 5 as they have not been received. In the next transmission, we get ACK received equal to 4. That is, we have to resend frame 4 and 5. Lastly, we get ACK received equal to 6. That is, all the frames have been received. Now, let's move to the next protocol, that is selective repeat. In this protocol, suppose we have window size of 5. Here we get no acknowledgement of some of the packet. Suppose we get no acknowledgement of 3, then we have to send third packet. No acknowledgement of 3 means received second packet, but we have to resend third. Now in this program we have variables p, I, a, w, nsc, ack. I is initialized to 1. I is used only for counter. Here a is our total transmission packets, total number of packets. W is our window size. Role of P will be explained later. And from NAC and ACK, NAC is no acknowledgement and ACK is acknowledgement number. Here we print our packet size. Now in this while loop, we print from which packet to which packet we are sending. In this for loop, we simulate which packets are being sent. NSE is randomly generated using rand function. Here, NSE is assigned value between I and I plus W randomly. If NSE equals I, we print acknowledgement number of W plus I, meaning which NSE we have received, we print acknowledgement number of that packet. Lastly, whichever NSE is there, we print sending that packet and acknowledgement of that packet. Now let us run this program and see the output. Here our packet size is 15. So since our window size is 5, we are sending 5 packets at a time. As we can see, we are sending packets from 1 to 5. Here we get NSE 2. That is, we are sending packet 2 again and we have received packet 1. Since we are sending packet 2, we have acknowledgement number of 3. Note that NSE of 2 means we have received packet not only 1 but also 3, 4 and 5, and we don't need to send them again. In the next batch of packets, we are sending 6 to 10. Here we receive NSE equal to 8. Therefore, we send packet 8 again. Here we have already received packets 6, 7, 9 and 10, and therefore we don't have to send them again. Here therefore we get ACK equal to 9 and ACK equal to 11 for 10th packet. Similarly, for the last batch of packets from 11 to 15, here we get NSA of 15, that is the last packet, and we don't have to send 11, 12, 13 and 14 again. So that's it from this video tutorial, as we have successfully simulated all the protocols, that is stop and wait, go back in and selective repeat. Thank you.